Let's start with today's daily lead code question. It's a medium one. It's called as closest prime number in range. We are given two positive integers left and right. We have to find two integers num1 and num2 such that they are both between values of left and right, and num1 is less than num2. Both are prime numbers, and difference between num2 and num1 is minimum amongst all other pairs satisfying the above conditions. We'll return our positive integer array num1 and num2. This is the condition. If there are multiple pairs satisfying this condition, return the one with the smallest num1 value. If no such pair exists, return -1 and -1. Right? Constraint is 1 and 10 to the power 6. We can take a look at the hint here. C of Eratosthenes. Let's start with the first example here. We are given left as 10 and right as 19. So we'll write the numbers between 10 and 19 here. 10, 11, 12, 13, 14, 15, 16, 17. Now we'll check for multiples 2 here. If it is divisible by 2, we'll mark this as false. This is multiple of 2, so we'll mark this as false. False here. 11 is not divisible by 2. Okay, we'll skip this. Then we'll check on 12. 12 is false. 13 we'll skip as it is not divisible by 2. Then we'll mark this as false. Then 15 we'll check, it is not divisible by 2. Then we'll check with 16, it is false. Then with 17 we'll skip, and then 18 we'll mark as false. 19 will skip here. Okay, then we'll start with multiples of 3. 11 is not a multiple of 3, we'll skip this. Then we'll move to 12 here. 12 was already false. Then we'll come to our 13 here. 13 again is not a multiple of 3. Then we'll come to 14 here, skip this as well. Then we'll come to 15, it is a multiple of 3. Then we'll mark this as false again. Then we'll come to here, already marked as false. 17 we'll skip as it is not a multiple of 3. 18 is already marked as false, we'll skip this as well. Then we come to 19, it is not a multiple of 3. Okay, this is how we will find the numbers. We'll basically check with prime numbers, multiples of prime number here, and this is called as C of Eratosthenes. This is how we find all the prime numbers between two numbers. What we got 11, 13, then 17 and 19. So we can make three pairs here, right? 11, 13, 13, 17, and 17 and 19. What is the difference? The difference is 2. Here is 4 and here is again 2. Okay, so as 2 and 2 is equal difference between two pairs, so we'll take one with the smaller num1 value. So num1 here is smaller than 17. 11 is smaller than 17, so we take this pair. We will output this pair. So again we will use our C of Eratosthenes here. Or our left was 10 and right is 19. What we'll do, we'll write all the numbers from 0 to 19 here, as 19 is the maximum number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
16 and 19. Now we'll mark the multiples of 2, 3 and 5 prime numbers as false. As the smallest prime number here is 2, right? So we'll mark these two as false already. Okay, now we'll start with multiples of 2. 2 is a prime number, so it is true. 4, 4 is multiple of 2, so it will be false. Also false, 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 and false. Now we move to 3. 3 is a prime number, so it is true. 9 is a multiple of 3, so it is false. 15 is also a multiple of 3, it will be also false. Now we move to 4. 4 is already marked as false. We'll move to 5 here. So 5 is a prime number, so true. Okay. All the other multiples of next multiples already are marked as false. Like this, I think we have got our prime numbers here. So we'll define 3 variables: result, previous, and minimum difference. Result will be a resulting array. Okay. Num1 and num2. Our left is 10. Okay, so we'll start with number 10. We take our first previous as -1 because we are starting with 0, so a previous number from 0 is -1. Now we'll check with 10 here. 10 is marked as false, so we move to 11 here. We replace this with 11, then we take a difference between 11 and 13. The next number will be 13, so the difference will be here will be 2. Then we move to 14. 14 is already marked as false, so we'll skip this. Again 15 will be skipped, 16 will be skipped, and we reach here 17, so we'll replace this with 17. So again we take a difference between 17 and 13. What we got 4, right? Now we move to 18. 18 is marked as false, so we move to 19 here. So this will be replaced by 19, and the difference between 17 and 19 is 2. This was the pair with 11 and 13, right? This was the pair with 13 and 17, and this was the pair with 17 and 19. So we will take this pair because the num1 value, that is 11, is less than, right? So we'll skip this pair, and this has a value 4 that is greater than 2, so already this is skipped as well. So we got the output as 11 and 13.
Let's start the output part now. Firstly, we'll define our boolean here. Prime number right plus 1. Now array dot fill prime, that is true. Right. Firstly, we are defining our corner cases here. 0 will be false. Prime of 1 will also be false. For int, we can take a prime as p. P is equals to 2. We'll start with prime number 2 here. And we'll do this till our right number, and p plus plus prime number P int I equals to P multiple to P. This is to basically skip checking for the same multiples of our prime numbers when we are marking the numbers as false by C of rest of an here. Okay, I will be less than right, then I will add this with P here. Okay. Now our prime number will be n of I false, right? We'll mark these as false. Now we define a result array here in empty and -1 and -1. This is was given in the condition will return -1 and -1 here. Now minimum difference will define integer max difference max value, I mean, previous here is -1, right? Or in I is left I plus prime of I and previous will be -1 will previous will be equal to I here, right? And else condition will be I minus previous is less than our minimum difference. I minus previous minimum difference will mark the result of our 0 as previous, result of our 1 as I, and minimum difference will be I minus previous. This is the difference of the left and right number. Oh, sorry, num1 and num2. Previous will be equals to our I here. We'll return our result here. Return result as, let's try to run it now. Cannot find symbol prime here. It is prime number, I think. Okay, sorry, prime number. So okay, so we can now submit it. Oh, outer bound. Uh, outer bound, right? It should be.